All right, limits, limits, limits. So determine the following limit in simplest form as x is approaching infinity. So we've got this big mess of information. Don't freak out right away. Go to your basics. Go to your foundational skills. So we've got a binomial times a binomial. What you want to start doing is just using the FOIL method, or however you were taught how to multiply binomials back in the day. Let's get started with that. So I'm just going to draw it out. 1 times 4, that's going to give me 4. 1 times x squared, that's going to give me an x squared. 10x to the power of 3 times 4 is going to give me 40. X to the power of 3. 10x to the power of 3 times x squared. We got to use our exponent rules here. Remember, bases are the same. We add the exponents. So we're going to end up with 10x to the power of 5 because 3 plus 2 makes 5. That's going to give me 10x to the power of 5. Can you guys see that? Yep, just barely made it onto the screen. Okay, now we got to do the bottom. We're multiplying this binomial times this binomial. Notice I hit every single mark. 10 times x squared, that's going to give me 10x squared. 10 times negative 3, that's going to give me negative 30. Negative x to the power of 3 times x squared, that's going to give me negative x to the power of 5. Remember, when bases are the same, add your exponents. And last but not least, negative times a negative makes a positive, and x to the power of 3 times negative 3, that's going to make positive 3x to the power of 3. Barely squeezed into the camera. Perfect. Look at that. Okay, we've got all this information over here, and now all we need to focus on is the ones with the highest degree, the ones with the highest exponent above them. So we've got a constant, we've got a power of 2, power of 3, power of 5. That right there is our highest exponent. Power of 2, constant, power of 5, that right there is going to be your highest exponent. So I circled the 2 parts that I need to use. I need to use those 2 parts of the entire expression. I'm only using 10x to the power of 5 over negative x to the power of 5. So how do I know to use those 2? It was the highest exponent. You just go to the one with the biggest value up there as an exponent. Now that I have this, we need to recognize there's a negative 1 right there. Sometimes my students forget that we actually have a value of 1 right there. Okay, x to the 5th, we're dividing them. So these are going to cancel out. And all I'm left with is a 10 divided by a negative 1. That's my horizontal asymptote right there. That's my limit. 10 divided by negative 1 equals negative 10. So when you go onto the graph, down here at negative 10, what we're going to have happen is our function is going to limit out there. We would have a horizontal asymptote at negative 10. All right? And that's how we do it. Multiply these 2 binomials together, multiply those 2 binomials together. Now that things are simplified, both the numerator and the denominator, we go to the highest degree, write those 2 pieces of information down, simplify it. We were left with a value, therefore we have a horizontal asymptote at that value. Study hard and good luck on your upcoming test.